Hello. Today we are starting CCNA7 and we are simply discussing networks today. Now this is the first model in CCNA7 level 1. Even though we have met and I have done some introduction with respect to this topic, I'll simply go over for the benefit of those who are not around to have a full grasp of what we discussed earlier. Then we can move on and continue from where we left previously. Networking today. Our model objective is to explain how networks affect our daily lives. We all agree that computer networks have an effect on our lives, and we are going to discuss that. We'll also explain how hosts and network devices are used. We'll also explain network representation and how they are used in network topologies. Then we'll compare the characteristics of common types of networks and the common types of networks. And then we'll look at how LANs and WANs interconnect to the Internet. We'll also describe the 4 basic requirements of a reliable network and explain how trends like bring your own device, online collaboration, video and cloud computing are changing the way we interact. We'll also identify some basic security threats and solutions for all networks. And lastly, we'll explain employment opportunities to the networking field. How do computer networks affect our daily lives? Communication is almost as important to us as our reliance on air, water, food, and shelter. Now, in this our world today, the use of computer networks have brought us together, connected us like never before. Now, you agree with me that computer networks have made our world a world without boundaries. You agree with me also that computer networks have affected the way we play. In the olden days, and for that matter in the part of our world as Africans and Ghanaians, we used to have our cultural way of playing. We used to play within communities, and then we used to play with our neighbors. But today, you agree with me that through computer networks, we can sit in the comfort of our homes and play games with people we don't even know elsewhere. We have different types of games. We have different types of platforms that we use to play, and we can have multiple number of people whom we can play computer games with from different parts of the world. And this has truly made our world a global village. You will also agree with me that computer networks have also impacted positively on the way we communicate. In the olden days, people used to walk from cities to cities, from communities to communities, to be able to meet people and discuss very salient information that regards family, that regards business, that regards all other things. But today, with the advent of computer networks, we have been able to communicate effectively in real time. We don't need to travel distances to be able to have information carried across to our neighbors, to our friends, and to our business partners. Today we have so many computer networking platforms that has helped us to be able to communicate in real time. We have our social media bundles, we have the WhatsApps, we have the YouTubes, and so many applications that help us to be able to communicate real time with our peers, with our teachers, with our business partners, and all. Thirdly, computer networks have also impacted the way we study. You agree with me that if anybody had an admission in a particular institution, either in his home country or abroad, that person will have to go through a lot of bureaucracies and will have to satisfy a lot of international requirements before that person will be allowed to cross the border. Some of these things are: you need to get a passport, you need to get inoculated with specific vaccines, you need to pay or find money to pay for your visa and your ticket. And then you also need to go through so many rules to be able to find yourself in another person's country. And even when you get there are cultural diversities, and to be able to fit in is also another thing altogether. So you look at all the stress that one will have to go through, and then all the risk one will have to take before he leaves his home country to go and study in another person's country has made it very laborious, or made it very, very laborious then. But today, the advent of computer networks have removed boundaries. Now, even with the advent of coronavirus, a lot of institutions are running online programs where students stay in their home country and then communicate with their lecturers and then study, send their assignments, and then get required feedback from their institutions. And this has taken away all these bureaucracies one will have to go through to be able to find himself personally in a particular country or in a particular community to study. So computer networks have made our world a world without boundaries, where everybody or anybody who uses it can have access to anybody at any point in time, without any tax, without any toll, without any rules and regulations that we will have to follow to be able to reach out to the person. Now, through that, it has made our world a global community. Now, if you use social media bundle, you can be part of a specific groups with respect to the specific discipline you want to be with. If you go on Facebook, there are a lot of groups that discuss specific matters of interest, which you can join. And when you join such groups, irrespective of wherever you are coming from, you have a mutual way of communication, which has brought all or everybody in every part of the world together to make the world a global community. There are so many more we can discuss with respect to the world without boundaries and global communities, but we restrict ourselves to these ones so that we can move on. We want to discuss network components. What are network components? Network components are every member of every device that can be found on a computer network. So any device that has a name that contributes to the transmission of data from source to destination is a component of computer networks. Now we have devices we call the hosts. Now every computer on a network is called a host or an end device. An end device is simply the device that the end user or the user uses on a computer network. So every device or any device that the user directly uses to access information or to communicate or to use it to have access to services on a computer network, or can be used to communicate on the computer network, is what we call a host. So every computer on the network is called a host or an end device. Now, we also have servers. Now, servers are computers that provide information to end devices. Now, as their name implies, the servers provide specific services. So any end device that takes a service from a server is called a client. So you see this is a representation of a server, and a client, which is an end device or a device that the user is able to use to access information from a server. So any device on a computer network that takes information from, or that requests information, or that the server provides information is a client. Now, servers provide so many services, and some simple ones are the email services. Now, these email services are provided, for example, an individual who finds himself connected to an internet network and has an email account with a particular service provider. For example, Google provides email services, Yahoo provides email services, so many companies provide email services. So when you subscribe or you identify yourself with such a company or a group that provides these services, know that anytime you go into your inbox to check your email, you are requesting for an email service from a particular server. For example, if you have a Gmail account, if anybody sends you an email, it goes to the email server for Google. And when you sit behind your machine as a client, and then you request to read that email, you will be taking a service, that email service from the server. through the internet. So the web services allow you through a web browser to be able to access data or access information from the server. And some of the services the server can provide are email services. In the same way, when you are trying to access this information from the server through internet, the server will also be providing you with what? Web services. Because as soon as you open up a browser, you type a web address, the web address of the server begins to give you web services. The server also provides you with file services. And we can number a myriad of services servers can provide. These are just a few. File services. Now you have an institution, you are a student, and then your lecturer puts an information on a server, and as a student you are able to download that information. You realize that that server will be providing you a file service. For example, a document or an assignment. If you have the ability to access that particular file from that particular server, that server will be giving you a file service. Now, clients are computers that send requests to the servers to retrieve information. Web page from a web server, email from an email server. So an email server runs email server software. Clients use client software to access the email. The web server runs a web server software, and then the clients use a browser to access the web pages. A file server stores corporate and user files. The client device accesses these files. We want to discuss what a peer-to-peer network or a peer-to-peer connection is. Now, a peer-to-peer connection or a peer-to-peer network is simply a computer network that makes it possible to have a device to be a client and a server at the same time. Now, this type of network design is only recommended for small networks. Now, when you look here, this type of network can exist between only two devices. So this is one device, this is also another device, and the two devices have a connection between each other. That means that they are able to share resources amongst themselves. And then they are also able to share a printer. Now this printer is connected to this particular host, and who is ready to share, and this particular host also is ready to share files that are on it. So this is a typical example of a peer-to-peer network. Now this type of network has its own advantages and disadvantages. Because it's simple, it is easy to set up, it is a simple network, and it's less complex. Now, it is used for simple tasks like transferring files and sharing printers. Now, its disadvantages is that there is no centralized administration. So when you look at this particular network, nobody controls the network. Nobody administers the network. Every host here stands on its own and cannot control anybody or any other host on the network. So there's no centralized administration. Now, it is not secure. All the files that are shared are also not secure. And it is not scalable. Now, scalability is the ability to accept growth and expansion. Now, anything that is added to this peer-to-peer connection will not make it a peer-to-peer again, and therefore this type of network does not accept growth, or does not accept other hosts to be part of the network. So it is not scalable. It cannot grow. You cannot expand. And then you envisage slower performances. Now we want to look at end devices. Now, an end device is where a message originates or where it is received. Data originates with an end device, flows through the network, and arrives at an end device. Now, look at this network. This is a local area network. So, data originates from a user here, and the machine he's using here is an end device. Now, this data flows through a network, and this is an internetwork. So, for example, you stay in your office or you stay in your home, and you send an email through a web service, and the internetwork is what we call the internet. And it goes through the internetwork, and then the person who's supposed to receive that email also sits behind an end device to be able to receive it. So every time data passes through a network from source to destination and vice versa, they are starting from an end device and ending at an end device. Now we have what we call the intermediary devices. The intermediary devices interconnect each end device, or they interconnect end devices. Examples include switches, wireless access points, routers, and firewalls. Now, when you look down here, these are theoretical representations of specific network devices. For example, with Cisco and other networking literature or tutorials or books, we realize that a LAN switch is denoted by this symbol. A LAN router a wireless router is denoted by this symbol. A router itself is denoted by this symbol. This is a multi-layer switch, and this is a firewall appliance. Now, even before we go on to discuss intermediary devices, we want to know what some of these network components are. Now, when we take a switch or a LAN switch, we also call it a concentrator. Now, what happens is that this particular device brings a lot of hosts or end devices to be connected to a computer network. Now, these networks or these end devices, these communicating or intermediary devices are the devices that hold or that supply end devices with the services or data that are running through the computer networks. So, as we move on, we'll take these devices one after the other and look at the real things they do and the proper descriptions. Nonetheless, I want to talk about them briefly. This is a router. Now, a router originates its name from the word route, R-O-U-T-E. Now, a route in English is a path that can be traveled, or a path that people can use to reach a particular destination. So if it is a path, and we say this is a router or a router, it means that this device carries data from the network or carries data to and from the network. Now, it is the device that selects the best path that packets will have to travel. It is the device that reads and then channels packets to which part of the network and then makes sure that it does flow control and then error correction and then send packets from one network to the other. So when you look at the internetwork here, you see this is a LAN, but you can see some routers here, and these routers are the intermediary devices that are supposed to what? Decide on which path they have to take to reach this network. So when we call it a router, we say it's a router or a router. When the frame reaches the first router here, this router is going to make a decision on which router will have to receive this information, because this particular information is intended for this network, and it will decide which path it has to go with the lowest cost to be able to reach who has to receive it. So this is a switch. The switch concentrates users. So this is a user, this is a user, this is another host. This server is also managed by a person, and therefore it's an end user device. And then this is an IP or Internet Protocol phone that's also kept in the office and used by users of the network or people in that office. And this is also an end device. So you realize that all these end devices are taking or are joining the computer network through this switch, because this switch has a number of ports. So if you want to count the number of ports on this switch or these end devices are connecting to, we can count 1, 2, 3, 4, 5. And these are the connected ports on the switch. We could have other ports that have not also been connected. Now, why are these end devices connecting to this switch? Because this switch is carrying a particular service, or it has a connection with another device that will be able to carry the packet that it receives to the destination network that has to receive it. So as you can see, these end devices, when data is originating from any of these end devices, it goes through a switch as an intermediary device, and then the switch also pushes it to the router, and the router also decides which of the routers that are in the internetwork that will have to receive the packets and also channel it to that network that is supposed to be the recipient network. And when it gets into this network, this router will also forward it towards another switch before the end users in that network can also have access to it. So the communication or the intermediary devices are the switch and then the routers. And then the end devices are the servers, the computers, and the IP phones and all that. So these ones serve as the recipient devices, and the intermediary devices also serve as the devices that carry the information to and from a particular network. So these are the devices. So if you say a multi-layer switch, it means that there's a number of switches that have been uplinked to have a number of layers so that a lot of people can connect onto it. And then we have this one also signifying a firewall device, which is a device that does intrusion detection and intrusion prevention, and it is kept at a particular gateway of a particular network to make sure that it screens whoever is coming in, authorized or deny whoever is coming in and going out. Now, the next thing we want to discuss is networking media. Now, when we talk about media, we want to talk about the channel with which information or data travels. So, communication across a network is carried through a medium which allows message to travel from source to destination. Now, we have certain types, or we have media types, or we have certain medium or a medium which data can travel, and we have the types. We have the metal wires within cables. The metal wires within cables. And the metal wires are normally copper wires that travels, or that data travels through them through electrical impulses. For example, we have the coaxial cable, which we call the TV cable. We have the twisted pair cable, which we normally call the patch cable. And the patch cable has a lot of categories. We have from category 1, category 2, category 3, which we call which has the RJ11 connection. And then we have what we call the beta UTP that starts from category 3 to category 8, which we call the beta UTP. And we say they are beta because they normally have 8 wires that can be found in the patch cable. The next time we will have a practical discussion and a practical touch on it. We will see how a patch cable looks like, or a beta patch cable looks like. And we have what we call the full duplex category cables, which have both sending and receiving wires. So you have 2 wires that are dedicated for sending data and 2 wires also dedicated for receiving. So you realize that in that medium, the sending pattern goes through 2 wires, and then the receiving pattern also goes through 2 wires, that is what we call the full duplex transmission. In this type of transmission, there is no collision because 2 dedicated wires are given for sending and 2 wires are given for receiving. A typical example we can use is the road. If you have a dual carriageway, you have one side of the road for only devices that are going, for only cars that are going, and then we have the other side of the road carrying or having cars plying for only cars that are coming from the opposite direction. And you see that whenever you have a road like that, the incidence of accidents are reduced. The incidence of congestion are also reduced. And this is what happens when you have a beta UTP doing a full duplex transmission. And then we also have another medium which we call the glass or plastic fibers within the cables, which we call the fiber optic cables. Now, with this one, the transmission of data through the glass is with the use of light impulses or light pulses. Now, we all know the speed of light. We can mathematically calculate the speed of light, and when we all know the speed of light, we know the milli or the nanoseconds with which light can travel from one point to the other. And that shows how speedily light carries data in the glass or in the fiberglass from source to destination. Now, these fiber optic cables, right, also have their own issues. Now, the issues that we need to discuss with respect to fiber optics are that we should be careful we don't get the cable an abrasion. An abrasion is simply the act of exerting a particular force that can break the glass within the plastic cable. Now, we all know that whenever a glass is broken, it either reflects or refracts rays. So when fiber cables are not kept well and there's an abrasion, and then a glass is broken, or the inside glass, which we call the core, that transmits the data, gets broken. When the light carrying the information hits at it, it will reflect. And when it reflects, it means that data will not be able to be sent to its destination. And that has its own repercussions. So it's very important that we have special care for fiber optic cables. Now, when we go on, or when we move in other chapters or higher chapters, we'll discuss the types of fiber cables we have, the single mode and then the multi-mode fiber, their connectors, and then their differences. We'll look at them. And then going back to copper, copper uses electrical impulses to also send signals and data across it. But copper also has its own problems with segment length or segment length of a cable. Every copper wire has a particular distance at which data or signal that is traveling on it will fall. Now, for patch cables, or for that matter, twisted pair cables, the maximum segment length for a twisted pair cable is 185 meters before signal attenuation. Now, signal attenuation is the fall of signal over a copper media at a particular distance. So, for the copper transmission, we have, for twisted pair patch cable, like the one we use in our computer rooms or in our internet cafes, and then we plug it into our network interface cards of our laptops and all that. If there's a connection with that cable at 185 meters within the network, there must be a regeneration and a retiming of a signal by a repeater or any other device that is able to regenerate and retime the signal to another 185. So that one has a segment length issue. Now we also have the coaxial cable. We have two types of the coaxial cable. We have the 10-2 coaxial cable, which has a segment length of 200 meters. Now, that 200 meters, the coaxial cable we are talking about are the ones we use for the television networks. We have the two types, which we use as the backbones. One is thicker than the other. The 10-2 and the 10-5. The 10-5 is thicker than the 10-2. The segment length for the 10-2 is 200 meters. And then the segment length for the 10-5 is 500 meters. The 10-5 are normally used as backbones for satellite connections, and the diameter of the copper cable within it are much bigger and stronger. It's not as easy to work with like the ones we use for our Go TVs and our DSTVs and all that. Those ones are the 10-2, which we also use for networks. So those are the copper media. They also have their segment lengths, a 200-meter point in a particular satellite connection, it must also have a repeater to regenerate and retime the signal to another 200 meters for 10 base 2. And then for 10 base 5, there is also the need to have a regeneration at the point where the cable is reaching 500 meters. So at that point, if the signal is not regenerated and retimed, the signal will fall, and that is what we call signal attenuation. Now, we also have the wireless media or the wireless medium. And with this wireless transmission, it uses modulation of specific frequencies of electromagnetic waves. So for the wireless medium, we have different wireless technologies. We have the infrared direct access, we have the Bluetooth connection. All of them have their own specific frequency which we operate, and we call those frequencies the unlicensed frequencies. Now, when we say they are unlicensed, it means that anybody can use those frequencies at any point in time. For example, you have a smartphone, you put on your Bluetooth, another person also put on your Bluetooth, and you share files. You don't pay to any organization, or you don't pay any money for using that spectrum, and that's what we call unlicensed and free frequencies. We also have what we call the wireless fidelity, which we call the Wi-Fi. It also operates in a specific frequency, and that is also an unlicensed frequency. And then, apart from that, we have the licensed frequencies, like the one the radio stations have been using, and the frequency modulation frequencies which are being used by the FM stations. For that one, you need, and then some of the television stations also use licensed frequencies. For those ones, you will need to have a subscription from officials. For example, the National Communication Authority for the part of our world will give you the license to be able to use those spectrum. And that is also another media for network transmission. Okay. Now, we want to discuss network representations and topologies. Okay, so here you can see end devices. And if we talk about end devices like we explained earlier, you see that we have computers, we have the laptops, we have the printers, and all the devices, telepresence endpoints, all the devices that the user uses. What are telepresence endpoints? Now, telepresence endpoints are the devices that helps organizations, that helps hosts to have a video conferencing activities. And that device that are showing the pictures to the other side, and then the cameras that are also taking the pictures from there are what we call the telepresence endpoints. Now, when we talk about intermediary devices, we want to talk about these devices that communicate with each other to bring services to what? The end devices. And we have a router, or the router, as a British would say. We have compiled switches, which we call multi-layer switch. We have a firewall, and then a router itself. And then, before these devices can have a connection with these devices, and these devices themselves to be able to connect with each other, for them to provide the services, we need a media or a medium of connection. So the connection could either be through a wireless medium, it could either be through a LAN media, which comprises of the copper media, the patch cables, which we call the twisted pairs, which we have two types, the shielded twisted pair or the unshielded twisted pair. And then we have the WAN media, which normally uses a serial WAN cable, which in the course of time I will show you. And these cables are normally used to have or to connect between routers, to connect routers together at wide areas. So the network diagrams, often called topology diagrams, use symbols to represent devices within the network. So these are the symbols. And then important terms to know include the network interface card, the physical port, the interface. Often the term port and interface are used interchangeably. Now we have two types of topologies. What is a network topology? A network topology is the arrangement of computer networks, and then either physically or logically. So the network topology, which is the arrangement of computer networks, have the physical topology, which illustrates the physical location and intermediary devices and cable installation. So the physical topology are what you can see, how it has been arranged in either a computer lab or a server room, how they are connected, and whether you can touch any of them. So the physical topology of a network is the physical arrangements of computer networks, and this comprises of the components of the computer networks, which are the devices. This comprise of the media or the type of connection, if they are cable connections, and then that is it. So you see that a physical topology diagram consists of network. These devices, these servers, have a connection with this switch, and their connections to this switch are through cables, and you see the cables that are connecting to the switch. Now this switch is also connecting to this router, and this router is also making a connection to this switch with a cable, and this router also has an internet connection. So let's assume that you have a university or you have a network, and a particular ISP like Vodafone or MTN is providing you internet service, and that internet service comes straight to your server room or to your router, and your router disseminates these internet services to all the end users through these networking devices or the intermediary devices. So this router is also taking service from an internet service provider, and it also has a physical connection. And don't forget that even Vodafone Broadband brings a cable straight into your house, and then it gives you a broadband connection. And how all these things are looking like physically are what we are discussing. And then you also have a connection from the router to a switch in a particular room 2124, and in room 2121 there's one particular host or one particular laptop connecting to it. In another room there's a rack that has a switch which we call the switch 4, and also has a connection, a laptop connecting to it, and you have in another rack. So in this room 2124 you have a rack that contains 3 switches. And in all these 3 switches, you have some classes that are making connection to it in different locations, but physically. So you see this laptop is connecting to it through a cable. This is also through a cable. This is also through a cable. And in this same network, from the router, the router also provides a service to another switch, and that switch also provides a connection to a network printer and another host in an IT office. So the physical arrangement of how the network is looking like is what we call the physical topology. Now, at the end of the day, when all these things are connected, physically and empirically, they don't just work, because these things must be put on, configurations will have to be done for them to be able to accept, to know each other, and before they will be able to communicate. So the logical topology diagram illustrates device ports and then the addressing schemes of the network. So now, in this same scenario that we saw in the physical topology, still you have a web server that is connecting to a particular switch, right? And this web server has a port behind it. So that cable, that is the patch cable that is coming from the web server, is connecting at port number 1, which we call the fast Ethernet port number 1. And that cable is coming from port 1 behind the server and is going to connect the switch at a gigabit Ethernet port 1. Now the email server is also connecting to port 2 on the switch. And then the file server is also connecting to another port from port 3. So you see, apart from the connections, there are other logical namings which has to do with the port numbers they are connecting to, because every decision that the router will make, sending information from this part of the network to this part of the network, is dependent on the ports that are connecting to it, where the data is coming from. That is what it's going to use to make its decision to send to whoever is receiving it. So port namings are very important in decision making. A typical example is, if you write a letter and you put it in an envelope and you send it to the post office, we can describe that as a physical topology of posting. But when you get to the post office will need the sender's address and the recipient address, so that when they pick the letter, the information that has been kept on the envelope will tell them where the letter is going before they will carry it to that person, so that the person who receives it will also know that this letter is coming from a particular sender, and will also update his memory on who has sent the letter. So those information are the logical information that are kept on the letter for effective posts. So all these ports, gigabit 1, gigabit 2, and all these, where all these connections are making, are the port names. So each device, let's assume that this email server sends an information that is dependent or that is meant for this particular PC. If it sends it to this switch, right, this switch will also forward it to this router. This router must know the port that it is receiving from. The information that are kept on the data must be for this particular F01 as a destination address. So when this one also picks it, it will know that this information is coming from this particular server through port 1, but the information on that particular data that has to be sent has a recipient information of F0/1. So when it gives it to this particular switch, this switch will also know that it's coming from this particular port of the router. And then it will also make a decision by sending it to F0/1 port for this machine to be able to receive it, because the information of the sender has also been kept on it. So that is how it works. And this is what we call the logical topology. Now, apart from this, apart from the ports, we have what we call the Internet Protocol addressing, or the IP addressing scheme. Now, this is a logical address that are given to every device that is communicating on the network to uniquely identify it, so that when information is being sent to that device, it will not be duplicated. For example, if you are a student and you go to an institution, the institution will have information on your records as your name, but at the end of the day, they will provide you an index number, and that index number is what is going to identify you from other students, because for your name, you can have the same name as another student, but when they provide you index numbers are different numbers, and that will uniquely identify you from other students. So, for example, if you have two students called Samuel Johnson in a networking class, what will identify or what will differentiate the two students? Their what? Their network, their index number, which is their identification numbers, which can never be the same. So if there's supposed to be a query on any of these students, when you query with the name, the two students, then the names for the two students will appear as the same name. But then when you query with the index numbers, you get the right person you want to associate with. So the index numbers are there to uniquely identify you. In the same way, networking devices, for that matter, hosts on the network, and then even the network intermediary devices, which we call the nodes, are also uniquely identified. So whenever information or data are being sent from one source to the destination, once they are going through the ports, the information that are carried on the data are also the unique addresses of who is sending what and who is receiving what. So all these things happen without your physical knowledge. You cannot see them. So when you fix the cables, right, it doesn't just end there. These operations will also have to go through before a particular information or data is sent from source to destination. And all these things are logical operations which you cannot see with your eye. When we say something is logic, it is happening, it is true. And computer networks have the physical topology and the logical topology. A network without a logical topology is incomplete. And a network can also exist without a physical topology, because the logical topology cannot exist without a physical topology. And then a physical topology can exist, but without logical operations, there will not be effective data transmission. Now, we want to look at common types of networks. Now, we have what we call the small home networks. Now, these networks connect a few computers to each other and then the internet. So this is a small home network. And you realize that these are standalone machines, and they connect a few computers. Now, these standalone small home networks grow into what we call small home and office networks, which enables computer within the home or remote office to connect to a corporate network. So here you see that this is a particular office, this is another office, but these two sub-offices have a connection with each other, which we call the small home and office network. And then we have what we call the medium to large networks, and which are small personal area networks that are connecting each other within floors of a building. So inside this building we have 3 floors. This personal network connects to this personal network, and all these networks also connect to the second floor, and this second floor also connects to the 3rd floor, and we call it a medium to large networks, and many locations with hundreds and thousands of interconnected computers. And then we have the wide area network, which we call the worldwide network or the internetwork, which connects hundreds of millions of computers worldwide, such as the internetwork or the internet. Now, we have what we call the local area networks and the wide area networks. Now, network infrastructure vary greatly in terms of size of the area covered. Now, the number of users connected, the number of types of services available, and the area of responsibility. 2 common types of networks are the local area network and the wide area network. Now, when you look at this diagram, this color represents a LAN, and this is a simple LAN, local area network. And what is a local area network? A local area network is a network that spans a small geographic area. Now, it could be within tables in a building, it could be within the same floor, communication of computers to share resources in the same floor, or in between floors, or in a particular small geographic area, like a campus environment. So this is a home office, and it's a simple local area network. Now this tablet has a connection to a wireless router. This laptop has also a wireless connection to a wireless router. And this printer has a physical connection to that same router. Now, whenever you see a cloud, you have to know that it's an internetwork, or we call that an internet. So this particular router is taking a service from internet service. This particular branch of the organization, which is this is a home office, this is also a branch, has a connection with the home office through the cloud or through the internet or the wide area network. So this, in effect, all the hosts here and all the hosts here can have a connection with the home office. And then the central branch also has a connection with the home office. And the central branch also has a connection with the branch office. And the branch office also has a connection with the central branch. And all these are internetworked. So this home office is a local area network. But these local area networks, we have a cluster of local area networks that are connecting each other through the cloud, and we call it a wide area network. So a local area network is a network infrastructure that spans a small geographic area. Now, they interconnect end devices in a limited area. They are administered by a single organization or individual. And then they provide high-speed bandwidth to internal services. And then the wide area network interconnects LANs. This is a LAN, this is a LAN, over a wide geographic area, typically administered by one or more service providers. and then they typically provide slower speeds links between ones. So here, this is a branch LAN, this is another branch LAN. Now, these branch LANs are interconnecting each other through a serial WAN connection. So this router, these two routers are the intermediary devices that are able to communicate in between the two networks. Now, this network alone can have a different internet service provider, and this one can also have a different internet service provider. But at the end of the day, the two different networks will communicate. That is why you say that they are typically administered by one or more service providers. Now, we want to discuss the internet. Now, the internetwork or the internet is a worldwide collection of interconnected LANs and WANs. So LANs connect to each other using WANs. So this is a home LAN. This is also a home LAN. This is also a hospital LAN. This is also a government LAN. This is also a business LAN. This is also a small local school local area network LAN. But all these LANs have a way of interconnecting each other, and we call it the internet. That is the more reason why you can sit in your campus network and then send an email to somebody in another country who is also in another local area network, but that person will receive your mail, and we call that inter-networks. Now, ones may use copper wires, fiber optic cables, and wire transmissions. Now, the internet is not owned by any individual or group. The following groups were developed to help maintain structure on the internet. We have the IETF, which we call the Internet Engineering Task Force, and they maintain internet standards. We have also the ICANN and then the IAB. There are so many of them. When you look into or when you read the literature or the notes, you see what actually they do. Now, I want to discuss intranets and extranets. Now, an intranet is a private collection of local area networks and wide area networks internal to an organization that is meant to be accessible only to only members of that organization or only members with authorization. An organization might use an extranet to provide secure access to their network for individuals who work for a different organization that need to access their data on their network. Now, simply put, organizations' intranets only have authorized users who are members of the organization. But when they make part of their intranet accessible to their customers or other users or collaborators or suppliers through the internet, we call it an extranet. For example, Google as a company have their own intranet, and when you go to their premises, only members of the organization have access to their core network. But when they give you the ability to register with them to receive an email services, they are giving you part of their network to use as an agent or as a customer. And once you become a customer, you access that part of the network with an internet connection. So reaching Google or Gmail through internet to use part of Google's network that has been given to you as a customer is what we call an extranet activity. Now I want to discuss internet access technologies. We have different ways to connect users and organizations to the internet. One of the popular ways are the DSL services, which we call the digital subscriber line, which is which connects home users through a broadband cable, and then wireless ones and mobile services. Now, organizations envisage faster connections in order to be able to use their internet protocol phones, their data center storage, and then their video conferencing activities. And then the business class interconnections are also usually provided by service providers, which may include business digital subscriber line, the lease line, and then the metropolitan Ethernet. Now, these are all different types of internet services that are provided by different internet service providers. So you have different service providers providing different kinds of technology. We can talk about this digital subscriber line in our part of the world, which Vodafone provides as broadband. And with this one, they send you a line or a telephone line and a router. And the telephone line allows you to be able to dial into their system to provide you the internet service. In other parts of the world, there are what we call the leased lines. These are also lines that could also look like telephone lines, but these lines are given to you to your home when you build a new house or you have access to a premises. These lines are given to you, and these lines are the lines that will aid you to have the internet connection. And then we have the metropolitan Ethernet, where a service provider provides internet connection for a whole metropolis, where members of the metropolis can also have access to subscribe. So we want to look at the home and office or small office internet connection. So we have the DSL. This is an internet service provider that is taking internet services and providing these people with the internet. But the internet service provider can use any of these technologies. The digital subscriber line can also use the cable technology, can also use the cellular technology, which the MTNs and the Vodafones and then are providing for us, and then can also use the satellite services. Now, all these different types of technologies are available for service providers to use to carry internet across to the user, either a home user, either a teleworker. Who is a teleworker? A teleworker is a person who works for an organization at a remote area. So the person has access to the organization's network, but it's a teleworker or a telecommuter, but somewhere, but uses the network to work. And they can also provide internet through a small office. So you see, a cable is a high bandwidth, always on internet offered by cable television service providers. So some of the television providers can also or are able to provide internet services through the satellite connection that brings you your television. For example, MultiChoice or can also provide you internet services. Sometimes they use the internet on their network, and so at many times when you are behind or when you are nearer to their decoder, sometimes you put on your Wi-Fi and you're able to have internet access, and that's what we call the cable bandwidth or the high bandwidth cable television service. But when you go to other parts of the world, when they're providing you the television service comes with an internet connection for you to be able to use Netflix, for you to be able to use other smart connections and applications on your smart TV. We also have the DSL, which is the high bandwidth, always on internet connection that runs over a telephone line, like the Vodafone Broadband. And then we also have the cellular, which uses the cell phone network to connect to the internet. So once you have a smartphone and you have an internet, you have an MTN chip or a Vodafone chip, automatically when you buy data service, you have internet. And then we also have the satellite, which is a major benefit for rural areas without internet service providers. And then we also have the dial-up telephone line, which is an inexpensive low bandwidth options using a modem. And this is an obsolete or getting outmoded. But these services were the ones that were used to be around in the past, and then the service providers upgraded to digital subscriber lines and other modern methods. Now, still on business internet connections, you have a corporate business connection which may require a higher bandwidth, which may require a dedicated connection, which may require a managed service. A higher bandwidth simply means the pipe that can be, or the amount of service or the amount of database that are able to go through your transmission medium over time, which we call the bandwidth. If you need a higher number of bits to be able to travel within your transmission medium, you need dedicated connections and managed services. You have an organization and you have an internet service provider, and an internet service provider provides a dedicated leased line, provides a metropolitan internet or the business DSL, or through a satellite connection. Now let's look at this type of connection. We have a dedicated leased line. Now these are reserved circuits within the service provider's network that connect distant offices with private voice and data networking. Dedicated leased lines. So we say that they are reserved circuits. They are lines like the telephone lines that are for the service providers that connect distant offices with private voice or data networks. And then we have the Ethernet wide area network. Now this extends local area network access technology into the WAN. And then we have the digital subscriber line, which is available in various formats, including symmetric digital subscriber lines, SDSL. And then we have the satellite connection, which can provide a connection when the wired solution is not available. We want to discuss converged networks or converging networks. Now, before converged networks, an organization would have been separately cabled for telephone, video, and data. Now, each of these networks will use different technologies to carry the signal. So, before all these things merged, or single networks merged, organizations were having devices, and then they were connecting devices with computer networks using protocols. So a computer to a computer network was a single network, and an IP phone to an IP phone or connection was using a telephone network, and this is a telecommunication network. So before, we have a peer-to-peer or computer to computer network standing alone, and then we had the telephone networks also standing alone, and then we also had the television networks or the broadcasting networks standing alone. All of them individually were using rule, agreement, and standards. Now let's see what has happened. Now networks have been converged, and these converged networks carry multiple data services on one link, using data, using voice, and using service. So when you look at this, instead of the single networks, you have a computer that can have a connection with what? An IP phone. At the same time, having a connection with the computer itself. At the same time, having a connection with what? With the wireless devices. So you see, the single networks have all been converged using a standard, using an agreement, and using a rule. So converged networks can deliver both data, voice over the same network infrastructure. The network infrastructure uses the same set of rules and standards. Reliable networks. We want to look at what we mean by network architecture. Now, a network architecture refers to the technology that supports the infrastructure that moves data across the network. So if we want to talk about reliable networks, we want to talk about a network that is fault tolerant. We want to talk about a network that has a quality of service. We want to talk about a network that is scalable. And we want to talk about a network that has security. Now, what do we mean by fault tolerance? A fault tolerant network limits the impact of failure by limiting the number of affected devices. Now, reliable networks provide redundancy. Now, when we talk about redundancy of a network, it has to do with efficiency of a network. Now, when you talk about redundancy in English, redundancy is the exact opposite of efficiency. When you are rendered redundant in a normal parlance or in English, it means that you have been made inactive or you have been made ineffective. But when we come to networking, when we talk about network redundancy, it means that the network is efficient and it is effective. So when we talk about reliable networks, we say that reliable networks provide redundancy by implementing a packet switch network. So if we want to talk about fault tolerance of a network as a metric for reliability, then it's important we discuss what we mean by packet switching network. Now, packet switching splits traffic into packets that are routed over a network. Each packet could theoretically take a different path to its destination. So redundant connections allow for alternative paths if device or link fails. The user experiences are unaffected. So when you do packet switching, each packet could theoretically take a different path to the destination. So it means that when you provide a lot of redundant paths, when we talk about redundant paths, we are talking about possible areas where data and services can travel. So when you look at this network critically, you see that this network is connecting to this network, but it is not through a single cable, so that when one device is broken, it means that the whole network will go down. Now, we have multiple connections. This is one, this is also one. So you see that you have redundant networks, and we call this a packet switch network, where when there is a problem in one part of the network, data can use other routes to reach their destination. And when we have a network that is using a packet switching technology, which has redundant network, we say that that network is fault tolerant. Now, scalability. A scalable network can expand quickly and easily to support new users and applicants or applications without impacting the performance of services to existing users. So if a network should be reliable, the network should be what? Scalable. And that means that it must be able to accept expansion and support new users. And in doing that, it must not impact on the performance of the network. So network designers follow acceptable standards and protocols. The protocols are simply rules in order to make the network scalable. So you see this network. This network connects to this network, but there has been an expansion of this network, and this expansion is not affecting any operation. And we see that this network is a scalable network or has been scaled. So additional users and whole networks can be connected to the internet without degrading performance of existing users. So for reliability, we have discussed fault tolerance, we have discussed scalability. We want to discuss quality of service. Now, voice and live video transmissions require higher expectations for those services to be delivered. Have you ever watched a live video with constant breaks and pauses? Now, this is caused when there is a higher demand for bandwidth than available, and quality of service is not configured. So quality of service is the primary mechanism used to ensure reliable delivery of content for all users. With quality of service policy in place, the router can more easily manage the flow of data and voice. So when you look at this network, quality of service managed by the router ensure that priorities are matched with the type of communication and its importance to the organization. So web pages can usually receive low priority. So you set priorities of the applications and what people will use so that you can achieve quality of services. And a voice over IP call will need priority to maintain a smooth and uninterrupted user experience. So it depends on the network and then the policy of the organization. Depending on the policy of the organization, you set priorities, and then your priorities will show which one needs more traffic and which one needs lower traffic in order to prioritize data usage and then bandwidth usage on the network to achieve quality of service. Now, no network can exist and be reliable when there is no security. We want to discuss two main types of network securities. We want to discuss network infrastructure security. We want to discuss physical security of network services. We want to discuss the prevention of unauthorized access to the devices, and then information security, which is the protection of the information of data transmitted on the network or over the network. Now, the three goals of network security are confidentiality. Now, only intended recipients can read the data. That is very important. Integrity. You must be assured that the data has not been altered during transmission, and that's data integrity. And then availability, assurance of timely and reliable access to data for authorized users. So, if you want to talk about the goals of network security, you must make sure that the information or the data is there's confidentiality in the data that is transmitted. There must be integrity, and then there must be availability. So when you look at this scenario, administrators can protect the network with software and hardware security and by preventing physical access to the network here. So if anybody wants to enter here, the security measures must be on this part of the router to protect the network from unauthorized access. Network trends. Now, the role of the network must adjust and continually transform in order to be able to keep up with new technologies and new end user devices as they constantly come to the market. Now, we have newer trends that affect organizations and consumers. We have the first one is what we call the bring your own device. Now, bring your own device. Now, we are people working with gadgets all around us. Everybody has a phone, everybody has a tablet, everybody has a laptop. And therefore, we depend on what people have to be able to communicate with them. And that's what we call the BYOD. We also have what we call the online collaboration. We have what we call the video communication and cloud computing. Now, bring your own device allows users to use their own devices, giving them more opportunity and greater flexibility. Now, this trend allows end users to have the freedom to use personal tools to access information and communicate using their laptops, their netbooks, their tablets and smartphones, and then their electronic readers. So, BYOD means any device with any ownership can be used anywhere. Now, another trend we can also discuss is online collaboration. Now, collaborate and work with others over a network on joint projects. Collaboration tools, including the Cisco WebEx, which we'll be using or which we have been using, gives users a way of constantly connecting and interacting. And then collaboration is also a high priority area for businesses and education. Now, the Cisco WebEx Teams is a multifunctional collaboration tool. It helps you to send instant messages to your team members. It helps you to post messages and post videos and links. Now, apart from the Cisco WebEx Teams and then the Cisco WebEx for meetings, there are so many collaborating tools or collaboration tools on the market or applications that we can find and also use. Now, the next network trend is video communication. Now, video calls are made to anyone regardless of where they are located, provided you have a good network or a consistent internetwork. Now, video conferencing is a powerful tool for communicating with others. Now, the media uses the video conferencing platform to speak to resource people from remote areas, and they speak to them directly as if they were in their offices. And it's a very powerful tool. Now, this video conferencing is also powerful for interviews. It's also powerful for presentations, for teasers and Viva, and so many other events that might be deemed fit to be used. Now, video is becoming a critical requirement in effective collaboration. Now, the Cisco Telepresence powers is one of the working where everyone, everywhere. Cisco Telepresence powers is one way of working where everyone and everywhere. Now, cloud computing is also another trend that allows us to store personal files or backup data on servers over the internet. Applications can also be accessed using the cloud. It also allows businesses to deliver to any device anywhere in the world. So cloud computing is made possible by data centers. Smaller companies that can't afford their own data centers lease server and storage services from larger data center organizations in the cloud. So when you keep an information on the cloud, you are performing cloud computing. Now, there are 4 types of clouds. We have the private clouds that is available for general public through a pay-per-use model or for free, which we call the public clouds. And then we have the private clouds, which are intended for specific organizations or entities such as the government. We also have the hybrid clouds, which are made for 2 or more cloud types. For example, part custom and part public. And then each part remains a distinctive object, but both are connected using the same architecture. We also have the custom clouds that are built to meet the needs of specific industry, such as healthcare, media. And then they can also be private or public. Now, we want to look at certain technologies in the home. Now, we have what we call the smart home technology, which is a growing trend that allows technology to be integrated in everyday appliances, which allows them to interconnect with other devices. ovens must know what time to cook a meal for you by communicating with your calendar on what time you are scheduled to be at home. Now, smart home technology is currently being developed for all rooms within a house, and these are also the technology trends that we can find in the home today. We also have what we call the power line networking, which can allow devices to connect to a LAN where data network cables or wireless communications are not a viable option. Now, using a standard power line adapter, and this is an example of a power line adapter, devices can connect to the LAN wherever there is an electrical outlet by sending data on certain frequencies. So power line networking is especially useful where wireless access points cannot reach all the devices in the home. So this is an adapter that is able to transmit network signals at specific frequencies for other devices that do not have access to Ethernet to have a connection with. And these are also modern network trends. Wireless broadband. In addition to the digital subscriber line and cable, wireless is another option used to connect homes and small businesses to Internet. More commonly found in rural environments, a wireless Internet provider is an ISP that connects subscribers to designated access points and hotspots. So when we talk about an access point, there could be a device here that is giving Internet access to all other devices that can be found in a home. So the coverage is what we call the hotspot, the coverage where these devices can have access to the access point. It's what we call the hotspot. Now, wireless broadband is another solution for home and small businesses. Now, they use the same cellular technology used by a smartphone, and an antenna is installed outside the house, providing a wireless or a wired connectivity for devices at home. Network securities. There are security threats, and network security is an integral part of networking regardless of the size of the network. Now, the network security that is implemented must take into account the environment while securing the network, but still allowing for quality of service that is expected of the network. So securing a network involves many protocols or many rules, many technologies and devices, tools and techniques in order to secure data and mitigate threats. Now, threat vectors might be external or internal. So now, this is a firewall that is trying to sieve from the internet the external threats. And if the internal threat is able to go through a particular firewall and enters a particular host in the network, this host becomes a compromised host. And then the host becomes an internal threat to all other parts of the network. Now, external threats. We have viruses, we have worms and Trojan horses. We also have spyware and adware. All these are external threats. We have what we call the zero-day attacks. We have what we call the threat actor attacks. We have the denial of service attacks. We have the data inception and theft, and then identity theft. And then for internal threats, we have lost or stolen devices, accidental misuse by employees, and then we have malicious employees. What are the security solutions we can employ? Security must be implemented in multiple layers using more than one security solution. Security or network security components for home or small office network are antiviruses and anti-spyware software must be installed on end devices. And then we should also have firewall filtering used to block unauthorized access to the network. Now, larger networks have additional security requirements. They need a dedicated firewall system. They need what we call the access control list, which means that it must define or must have a list of what? Those that they will provide access. They must also have an intrusion prevention system and must also have a virtual private network. Now, the study of network security starts with a clear understanding of underlying switching and routing infrastructure. Now, we want to discuss the IT professional. And this has to do with the Cisco Certified Network Associate certifications. Now, it demonstrates that you have a knowledge of foundational technologies and ensures you stay relevant with skills needed for adoption in the next generation. Now, the new CCNA that we are doing focuses on Internet Protocol Foundation and security topics. It also focuses on wireless. It also focuses on virtualization. It focuses on automation and network programmability. Now, the DevNet certification at the associate, specialist, and professional levels validates your software development skills. Now, the specialist certification also validates in line with your job role and interest. Now, we want to look at networking jobs and employment opportunities. You can go to dirctor.kntagh, and when you click on careers, you can find employment opportunities by using the talent-rich matching engine. You can also search for jobs with Cisco partners and distributors. You can also search for Cisco Networking Academy students and alumni. So, in this chapter, what did we learn? Now, we have learned that through the use of networks, we are connected like never before. We have also learned that all computers that are connected to the network participate directly in the network communication, and they are classified as hosts. We have also discussed diagrams of networks, often use symbols to represent the different devices and connections that make up a network. We have also seen that a diagram provides an easy way to understand how devices connect to a large network. And then we can also say that we have learned the two types of network infrastructures, like the local area network and the wide area network. We have also discussed the small home internet connections, including the digital subscriber line, the cellular, the satellite, the dial-up telephone, and then we have also discussed business internet connections, including dedicated leased lines, metro Ethernet, and then business DSL and satellite. We have also talked about network architecture, that it refers to the technologies that support the infrastructure and the programs, services, and rules or protocols that move across the network. We have also known the 4 basic characteristics of network architecture, and we've seen that for reliability, you need fault tolerance, scalability, quality of service, and security. Now, we have also talked about recent networking trends that affect organizations, like the bring your own device, online collaboration, video communications, and then the cloud computing. We have also talked about several common external and internal threats to networks. We have also talked about larger networks and corporate networks that use antivirus, anti-spyware, and firewall filtering. And we have also known that they also have other security requirements like dedicated firewall systems, access control lists, intrusion prevention systems, and then virtual private networks. Now, the Cisco Certified Network Associate certification also demonstrates the knowledge of your foundational technologies. Thank you so much. If you have any questions, you can post them onto our WhatsApp group, or you can send that through the NetAcad platform, and I'll be ever ready to respond to them. Thank you, and God bless you.